Alright, students, so let's look at this question which in vectors. Let's see how we can do this proficiently. So you're given that L1 and L2 are given by these two equations here, right? Then after which, find the Cartesian equation of the plane containing the line L1 and the point here. So I think this is quite okay. What you need to do is just basically find a line. So it contains L1 here. So just right now what's L1? L1 has got 3, 2, 0 on the line. So this is like 3, 2, 0. Then D1 here would be 2, -3, 1. Okay. After which you need a point on the plane which is like 1, -3, -1. Okay. Now I'm going to let this point here be A. This is B. And let this be C. So for easy reference, so this will be my C. 1, -3, 1, and this is my A. Okay. So to find the normal, just take note, the normal will then be you need the two vectors parallel to the plane. That will be basically this over here, AC and D1. Okay, so the normal of the plane, what I need to do is just taking D1 cross with AC. Okay, that's it. So D1 will be 2 -3, 1 cross with AC, 1 -2, -5 -1. So we're just going to do this cross product here. So there you go. So the normal, we could just divide it by 8 here, will be 1, 0, -2. Okay. So in this case, the equation of plane will be R dot N. Just remember, you have a luxury of 2 points. Just always check your value there so that you know that your normal is correct. So 3 + 0 + 0, which is 3. So to check, I use A, then I'll use C. Okay, always check if you have the luxury to. Because if this equation is wrong, probably if subsequent part, you may also get it wrong. So it's quite bad if you don't check. So equation of plane will be R dot N, which is 1, 0, -2, equals to 3. So the Cartesian equation would be x minus 2z equals to 3. Okay, that's it. So the next part will be show that L1 and L2 are perpendicular to each other. What you need to do is just take D1 dot D2 and show that it's 0. Okay, that's about it. So part B should be quite fast. Part B. I'm going to take D1 dot D2. That will be 2, -3, 1. Dot with 1, 2, 4. That gives us 2 - 6 + 4, which is equal to 0. There you go. So since the directional vector, when you dot them, the dot product is 0. So it means the L1 is perpendicular to L2. Okay. So let's look at part C. Find the value of lambda and mu such that R1 - R2 is perpendicular to L1 and L2. Set the position vector of the points where the common perpendicular is L1 and L2. Okay, I think firstly try to understand what's the question. Because what's R1 - R2, right? Okay. Then this is perpendicular to both L1 and L2. Now, L1 and L2 are told to be perpendicular to each other. So we don't assume they're intersecting. I think that's the crux. Try not to assume they're intersecting. So let's say there are skew lines like that, right? So there are two lines. So one of it would be like that. L1 is here, L2 is here. Now we know that if they're perpendicular to each other, what will happen is actually, if I were to draw this out, this is L1. Okay, maybe I draw it nicely. Something like that. So L1, L2, this is 90 degrees. Okay, skew line. The angle between them can be 90 degrees. So this is 90 degrees. So they are 90 degrees, but they're probably they're intersecting or not. I'm just going to assume that they are skew as such, right? Now L1 minus R1 is a point on L1 and R2 is a point on L2. So you're told that these two, when we say R2 minus R is R1 minus R2. R1 minus R2. R1 minus R2. What we actually are saying is that, let's say this is, if R1 is C, point C, and this is point this is point P and this is Q. This is P and this is Q. Okay. What we are actually saying is actually OP minus OQ, which is actually just Q to P. meaning to say this direction here. This is R1 minus R2. Okay, so we are looking at Q to P here. So if you want R1 and R2, on this diagram here, R1 and R2 has to be perpendicular both line. It has to be this point here, where this normal, the normal here. Okay, let me just draw it out. So essentially, if you want, it means that a random point from a point from L2, R1 minus R2 is always any point on L1. So this direction, you want it to be perpendicular both lines. It has to be this direction here. This one. Perpendicular both lines just means normal, right? So this would be this is R2 and this is R1. Okay. So it has to be here. That's the idea. So this is R2 minus R1. This direction is R2 minus R1. Oh, R1 minus R2. R1 minus R2. Okay, R1 minus R2. Firstly, establish that, understand this diagram first. Because a point on R2 and R1, to be perpendicular both of them, it has to be the normal vector pointing upwards. Okay, that's that. So firstly, we're going to just find R1 minus R2 first. So I'm going to take R1 minus R2. R1 was given by 320 plus lambda 2 minus 3, 1 minus of negative 4, 1 minus 3 plus mu 1, 2, 4. Okay. Okay, so this is R1 minus R2, the 1, 2, 4. Okay, because it's perpendicular both, so I think we could just take, since R1 minus R2 is perpendicular to the line 1, so means it will perpendicular D1. So this case here, I'll just take R1 minus R2 dot D1. This will be 0. Okay. Similarly, is perpendicular to the second line. So I'm just gonna take D1 here, D2. Just dot. I think using dot product is easier. I don't want to find the normal because it seems like it's going to be very cumbersome. So let me just use this one. Then once I take R1 minus R2 dot with D1 equals to 0, R1 minus R2 dot with D2 equals 0, then I'm just going to expand it because then I have two linear equations. I just need to solve it simultaneously. So take note how I expand it is I just multiply this to minus 3 times minus 1, 1, 3 to this. Then similarly, if I go down to the next list here, what do this, multiply this and this, I'll get this. Then subsequently this, and this will get me this. So this is easier because it's already in the factorized form. Okay, so let's just take note of that. I wrote the wrong D2. Let me just rewrite that. D2 here is actually 1, 2, 4. Okay. So once you solve this two, you get lambda equals to negative 1. I just now make a minor careless mistake there, so just take note. 1. Okay, that's about it. So they ask us to state the point, position vectors of where the common perpendicular meets position vector. So meaning to say we just want to find these 2 points at this point and these 2 points. Okay, so R1. So R1 would be, you just substitute lambda into R1 and R2. See, this is the one. This is the point, the position vector on L1. Then after which point on L2. So you just sub L2, which is mu, into the line equation of L2, right? So just replace it in. Okay, this is like I always tell my students, this is like housing address. So if your mu corresponds to a value, you just replace it in to find that point there. There you go. Done. Let's look at the last part. Hence, find the length of this common perpendicular. Great. Let's try that. So drawing this diagram is very, very, very important. Now we have this 0.15 minus 1 is this point here. So this is 1, 5, negative 1. Then after which this point here is actually negative 3, 3, 1. Okay. If you want to find the length of this common perpendicular, you just have to find the distance between them. Okay. So basically this distance here, the common perpendicular. So that's that. So the length will be, you just find the length. So you just take R2 minus R1, doesn't matter what you get. So, or R minus R2. Okay. So R1 minus R2 modulus. Then will be, just take 1, 5, 1, 1, 5 minus 1. Minus of minus 3, 3, 1. Okay, what's that? So find the modulus will be 4 square plus 2 square plus minus 2 square. Key in calculator. This will be 4 square 16 plus 4, so it's 24. We just 4. There will be 2 root 6 units. Okay, so that's how we do this question proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.